Okay guys, this is a small update on the satellite tracker. As you can see, I mounted an antenna on it. Also, I have this limit switch in here. Pass the cable of the antenna through here. As you can see, it's kind of the sensor up. The electronic is inside here. Yeah, I added this. Two is supposed to be a giant antenna. I have the other pieces. It's just like it is too long, and then it hits this part. So I'm planning to mount the reflector here in the back, but it's a little too long, so I'm probably gonna do it for UHF. As you can see, I have integrated this in the code. This was a serial, and you see the next pass is in 40 minutes. Gonna start 5 minutes before, gonna start tracking it. But this is how I plan to use it. So I'm gonna get all this information from here, and then this well, not this part, but the code to fetch the data is from this guy here. I modify. I actually end up using half of his code and then another half of a different code for the tracking. I mean, with the JSON, because the JSON that this is not it. The JSON that I had before wasn't really working. So, but this is the West serial that I have in here, and I'm fetching the data from here, from this website. If I go back to the Arduino, you can see here that I have it's a little different in here because I use it for troubleshooting. So, but yeah, and this is my code, kind of. Yeah. You can see this is to get the data. Oh, and I forgot to also mention that I'm getting, let me see it in this. I'm using the calibration from this guy. He did a great job calibrating, creating a sketch to calibrate the sensor, because the sensor is kind of useless without the calibration. So yeah, I modified it a little bit too. I modify everything a little bit or a lot, depends on what I want to do. But yeah, this is kind of how the code looks like. As you can see, and this is what it is. I'm gonna show you the active tracking part of it. The position, and then this is the active tracking. I know that's the compass. Okay, this is the active tracking. As you can see, tracking, and this is actually how I have it. I'm trying to find a way to integrate it so they move both at the same time, but since I'm using this TNC and there is no real library for it, it's a little complicated because I have to turn them off and on kind of manually with a variable. As you can see, let me show you. So to get, You see, like here I have to use this thing to get this piece of code to actually get the motor to move. So I have to manually turn it on and off in this interval to create the micro step, and then I'm just mapping this here to have an idea of how many degrees I'm traveling. Yeah, you should see this is my division of the steps to 360. So that's how many steps I need to go, or micro step, to get 360. And then I divide in 360 to get the step size. But because of that, it's a little hard to get both of them to go at the same time. But yeah, this pass is coming in like 9 minutes. So another 4 minutes, this should start. They should start moving. Sorry guys, I'm just trying to set up this tripod so I can actually record the pass. I have a little compass on top to make sure that I'm getting the right angle. They just wait for the pass to start. Hopefully it's a long one. I didn't check how long it was, but should be good. Hopefully. Let me see. 10 more minutes to pass. And this is almost at 300 degrees something. I don't know, but it's close to the end, so most likely if the pass go over 360, it's gonna come back around to 1 degree. So it's gonna go around and then start tracking again from there. It loses a few steps in doing that, but then it recovers. I try to make it faster, but if I decide to mount a heavier antenna, then those fast movement is gonna create a lot of vibration, because the acceleration right here is not the same with the acceleration right here. So small movement at the bottom, at the base, translate in a huge movement here at the tip of the antenna. Yeah, and I have this small ball fan radio hooked up to it. To hear some satellites, but I still have to work more on the antenna. I also have this HKRF with a power pack too. So that I use to scan for the satellites too, and some other things that this have. Oh, the pass is starting already. This is my trusty VNA to tune the antenna. So since it's lower than 0 because it started 5 minutes before the actual pass, so but then it works its way up to the starting point. But right now it's tracking the satellite where it is at the moment, even so that it's for radio transmission. It won't be possible because it's lower than the horizon. So you're just shooting your RF into the ground and it won't get through it. So you need at least be horizontal. Most likely preferable higher. The higher the better, so you can have a straight line of sight. It works. So this is the space station. Oh, this pass is almost overhead, right overhead. That's why it's moving only vertically and it's not moving horizontally because the path is right overhead. So I guess it's gonna go all the way to 90 and then it's gonna turn around and start going down in the other direction when it reach 90. So this is gonna be a long pass. I'm probably gonna have to forward this video so it's not so long. it's a 0 degree kind of. Well, now it's 0 degrees. So now we have our horizontal path. It's barely moving on the horizontal direction. Most likely this is gonna be a long pass. So I use this compass to double check that it's pointing on the right direction. So this is the magnetic north, and then this is my true north, 15 degrees. Just need to adjust it a little bit. Yeah. So this is a overhead pass kind of. So most likely it's gonna go all the way to 90, and then it's gonna turn around and come back down the other side. It's moving very fast now. So it reached the limit. So now it's coming back to the other side to 1 degree. So because it went all the way to 360, so now it's gonna go back to 1 degree and then start coming down from there. I was readjusting for the step that it lost while it was turning around. As you can see, now it started coming down in the opposite direction. This is the space station that it is tracking right now. You can see this is kind of 30 degrees, 26 something. As you can see, it's very accurate. And then when it reaches 0, so that's gonna be the end of the path, and then it's gonna home itself and turn to the position where the next pass will be. It may be a different satellite, because right now I'm tracking 3 satellites at the same time. So it's almost reaching 0. on schedule. As you can see, here is my, let me switch. And now it's slowly turning towards north. As you can see, it's gonna go all the way to north, and then it's gonna move to the left 15 degrees to compensate to go to true north. And then from there it's gonna move to where the next satellite is gonna be the next pass. So this is 15 degrees to compensate for north. So if you can see the line there, 15 degrees. So very accurate, I can complain. And now it's coming, turning towards where the next pass is going to be. And there you have it, this is where the next pass is gonna be. And if I go to here, we're gonna see which one is gonna be the next one. So this is what it was doing, what it was tracking, now that it ended. So now we have a prediction for the next pass. It's gonna be the space station again in 45 minutes. And then after that we have this other first B1 in 400 something minutes. And as you can see, the star azimuth is almost 300 degrees. And it's gonna end at 50, so this is one of those that's gonna go around when it reaches 360. But yeah, as I mentioned before, I heavy modified this code from this guy. I'm using the calibration file from this guy. And I'm fetching my data from this website. So very good system until now. I look forward to make it better. But this is it, guys. Thank you for watching.